Thank you, Rorie, for inviting me, and thank you all for joining me here today. As Rorie mentioned, I've got quite a lot I want to say. My slides are going to be a little bit busy. I'm going to have to skip a lot of details. You will have access to the slides afterwards, so please don't worry. Okay, I also talk quite loud and quite fast, so I might step back a bit. I might jump around a bit, because that's the way I am. So anyway, but here we go. Persistent identifiers. So, a bit of an introduction. What's a PID? PID is a globally unique and persistent identifier. So it's one of a kind, and it potentially lasts forever, which is kind of a bit of an aspirational concept, but yeah, in theory it lasts forever. PIDs, they're underpinned by metadata, so that's really data about data. I'll talk a bit more about that in a second. Often those are standardized through some schema, or they can be, in some cases, completely customizable. A PID normally resolves to a landing page and not the actual research resource itself, where a landing page is really a web page. It contains rich metadata, and then ideally a link to the resource itself. Although PIDs and metadata are typically human readable, they're really designed to be machine readable. So the most well-known example is obviously that you would have probably come across is a persistent identifier put on your papers. So you can see an example of that here. You know, here's a paper, and what it has is it has this URL at the end, which is a digital object identifier, a DOI. And sometimes you'll see them written like this, and sometimes you'll see them written like this, although actually this capitalization is incorrect and shouldn't be used, but often is. And so what is this? Well, this is kind of the DOI name. It's got several different parts. And this is a typical example, but there can be some differences depending on the persistent identifier. But what you'll normally have is a proxy. So this is the resolver service. And depending on the PID, you'll have a prefix and a suffix. Now, if it's in this form, then the prefix, this will be definitely a completely opaque, unique random string. And the suffix is more customizable, so may or may not be quite as unique. But the point is they shouldn't really contain semantic information. And the main point is that this plus this is uniquely, globally, a unique global identifier. So it's the combination of the two that really makes this unique. So this could be a local identifier that you have, but actually it's the combination of the two that give it that uniqueness. So what's metadata? Well, a simple example is if you download a photograph or an image, maybe from a website, that digital photo would be the data. If you right-click on it and look at the properties of it, you probably see information about that photo, who took it maybe, what camera did they use, what's the pixel resolution, so on and so forth. All of those things are metadata. Now, for a PID, the metadata usually consists of information about the discovery and assessment of that particular output. It'll have information on how to cite that output. It'll have information on access, usage, provenance of that output, and also it may have information about associated research outputs and entities. PID metadata, in most cases, is actually available under Creative Commons 0, which means it's totally in the public domain, which means all metadata, really, you should think about what can be shared, because, of course, this will be in the public domain. But it also allows you to say, if something is sensitive, to announce that it exists without saying exactly all the details of that thing or necessarily sharing that thing. So if you have something and you say, okay, I can't share it, but I want to tell the world it exists, you could do that through the PID metadata. You'll see in that list that you don't really have the domain metadata, and that's because PID metadata can capture some level of domain metadata, but is not really what it's designed for. The domain metadata, that rich information, is usually included in the landing page. So here you have the PID metadata, and here you have the landing page for that PID, and that includes, this is a sample, it includes all sorts of information about that particular sample. that a domain expert would want to know. What basic problem do PIDs solve? Well, they solve the one-to-many problem. So a name or identifier that you've put on something might be locally unique within a context or a boundary, but not really beyond that. So how do I know that I found the right output or entity? And simple examples, you know, if a sample is named M1, how many M1 samples are there in the world? If your name happens to be Chieho Chen or Shufen Chen, it's a very common name, to my understanding, in Taiwan. If I'm looking for research by one of those people, how do I know I found the right person and their research? Okay, so in ResearchGate, there's 3 of each. That's not so many. That's maybe not difficult. In LinkedIn, there's over 100 people called Shufen Chen who have profiles. So, I mean, you know, you could be needle in a haystack. It also solves the many-to-one problem. So a name or identifier can actually change over time or as a research object moves across organizational boundaries. So how do I know if it's the same thing? How do I know if it's a different thing? So again, a sample could have many, many names, or a person's name could change through marriage. It could change again through divorce. It could change again through remarriage. It could also be referenced in a number of different ways. How do we know that this Shufen Chen is the same as this one, is the same as this one? You know, what if Shufen Chen also has adopted a Western name? How do we know this is the same Shufen Chen each time? So this is what a persistent identifier really is basically trying to solve. So what common PIDs exist? What are they used to identify? Well, again, the most common example, the one that's well known, is obviously journal articles. These are typically registered with Crossref digital object identifiers. Crossref is a member organization. It has 24,000 members across the world. They're publishers, journals, funders. There's about 200 million of them. They have a specific metadata schema. Because it's a member organization, only members can actually create these Crossref DOIs, and that comes with sort of associated fees. If you're not using a Crossref DOI, there are alternatives, including DataCite DOIs, handles, archival resource keys. I'll talk a bit about those later. For research outputs beyond journal articles, and in some cases including journal articles, you would normally use a DataCite DOI. DataCite, it's also a member organization. It's got about 1,700 something members worldwide, mostly research institutions. That includes direct members and also consortium members. There's about over 100 million DataCite DOIs. That's across 30 different types of research outputs. Again, it has a dedicated standardized metadata schema. Again, it's only members can actually create DataCite DOIs, and there's fees involved in that. And alternatives, again, could be handles or arcs. What about PIDs for physical things? Well, these are a little bit more complicated because there's multiple organizations involved, but you have PIDs for material samples. These are mainly the international generic sample numbers. They were originally developed by the IGSN organization, but actually IGSN has created a partnership with DataCite that they're now under the DataCite DOI infrastructure. So the EV itself has 14 members across 6 countries, mainly geoscience research institutes, but because this is now under DataCite, there's actually greater than 30 organizations using IGSN IDs, because the main point is you need to be a DataCite member to create them, and the fee model applies, although there is a separate fee for EV membership. There's about 14 million IGSN IDs at the moment. Alternatives include, again, general DataCite DOIs, handles, arcs. That also includes, which you may have heard about or may not, the distributed system of scientific collections, which is also partnered with DataCite, and that creates kind of digital representations of specimens. Then we've got instruments. So again, this is a little bit complicated. They're normally identified using either EPIC handles or DataCite DOIs. DataCite DOIs you already know about. Epic handles actually aren't through Epic itself, but through what's known as B2Inst. It's a platform, and that's actually through UDAT, which is a European organization. It has about over 20 members. About 12 of them are using this B2Inst. It's mostly data centers, research organizations. There's about 4,000 Epic handles and datasite DOIs for instruments. It has a very specific mapping that was developed in the Research Data Alliance called PID-INST. That's directly mapped into the datasite schema, but is used wholly within B2Inst. EUDAT, it's more of a technological than financial organization. Obviously, if you're with DataCite, usual DataCite fees apply. And again, handles and ARCs would be an alternative. And what about PIDs for research entities? Well, so for researchers, you have ORCID IDs. These are provided by ORCID, which has about 1,500 members. There's 11 million active ORCID IDs, plus one assumes a number of dormant ones. It also has a dedicated standard metadata schema, but I don't know what it's called. One of the things that's useful to note is that it is free for any researcher to create their own profile, get their own ORCID ID, have their own ORCID record. But of course, the power of this really comes through the development of integrations by organizations that can sort of write to ORCID records. And for that, you do need some sort of direct or consortium membership, and then there are fees involved. And an alternative is ISNI. So ISNI is the International Standard Name Identifier. It's an ISO standard for naming people and organizations. Then for research organizations and funders, we have ROR IDs. So ROR is a global registry of research organizations. It's not a member organization. It's actually funded by several stakeholders, including Crossref and DataCite. There's 116,000 ROR IDs at the moment. Again, they have their own metadata schema. There's no fee involved in having a ROR ID. If your organization happens to be missing, you just contact them and they'll create a record for you. Again, ISNI is the main alternative. There are Crossref funder IDs, but these are transitioning to ROR IDs anyway. Grids, they've already been depreciated and moved over to ROR IDs. So ROR is really the main thing for research organizations and funders. And PIDs for grants. So we're connected with the funders. We have grants or awards. Nothing really new or extra to say here because they're both coming through Crossref and DataCite. So Crossref have grant IDs, DataCite has award DOIs. There's nearly 200,000 of them. They're captured in the typical metadata schema. The usual membership fees apply, and ARCs and handles are the main alternative. Now, you'll have seen of all of these things, and they all kind of come together. There's a research entity at the center of all of these inputs-output entities that really kind of binds them together and has been missing for a long time. And hopefully it should be fairly obvious to some of you in the room at least, but that thing that's missing is projects. So now there is a PID for projects called RAID, and this is what I'm working on currently. So RAID is fairly new. It's an up-and-coming PID. It's an ISO standard governed by the Australian Research Data Commons, ARDC. It's got a slightly different model in that it's looking to set up registration agencies within countries or for communities' domains to form this global operating alliance. Because it's fairly new, there's not so many of them. There's only about 500 of them. It is kind of offered in a partnership, so it uses the DataCite DOI infrastructure, again has its own metadata schema. Fees, well, it is, for Australia and New Zealand, it's free through ARDC. As other RAs are set up, they may have different business models, and that's up to them to decide. And again, alternatives, DataCite DOIs, handles, ARCs. Can't go into the details of it now. Come and talk to me. I'm here all day if you want to ask me a bit more about this. But I would argue it is in the national interests of Taiwan to really consider a path towards maybe becoming a RAID RA in the future. Right, I've mentioned arcs and handles a number of times. These are known as, or termed, locally governed PIDs. They're a little bit different because actually what happens is instead of there being this kind of really global organization that operates everything, you actually create your own local servers. So local servers can in theory be set up and maintained by anyone. It's a relatively low financial cost for doing so. In theory, you have unlimited identifiers. It doesn't impose much of a metadata upon you, very, very light, and the metadata there on top of that is very customizable. It can be used generally, but it's very, very useful in particular for internal identification of outputs and entities. It's things that you may not yet or ever want to put out in the public domain, but you still want to, or publicly expose, but you still want to be able to internally identify them, or things that have very, very high granularity. So, for example, a subsample, a sample could be subsampled multiple times, and you end up with this hierarchy of things that all lead back to the original. You may only want an IGSN on the parent. You may not want IGSNs all the way down. More of a sort of neutral thing that I want to highlight is it's not free. There's this misconception by some people that somehow you're getting unlimited identifiers for free. It's not true. There is still money involved, and there's still a lot of expertise that's required. And the point is here that it does heavily rely on local or institutional infrastructure. So basically, it lasts only as long as the server is paid for and the infrastructure is continued. That persistence isn't guaranteed. They do have a lot smaller recognition. That can potentially limit exposure. There's a lot of varying, because there's no real kind of community or standardization, the research data management and metadata practices can vary, so there can be low interoperability. There's really a much weaker community support. Sustainability, troubleshooting can be difficult, and they don't really carry the same level of trust and reliability as the other PIDs. A lot of these organizations you'll have seen in my previous slides were pretty much attempting to do things by themselves. They came together to partnership with DataCite. There's kind of a reason for that. It's not easy to go out and do these things by yourself. So the dream and the realities of PID adoption and usage. So the dream is that everything has a PID that should have one. All those PIDs have rich metadata, they're all harvestable, and in this case, PIDs can all work together to optimize the research lifecycle. Now, unfortunately, I really don't have time to go through this, but I encourage you to go and have a look at this work done by More Brains. They created this really beautiful idea of kind of this unified, optimized research lifecycle. But what are the realities? Well, not everything that has a PID should have one. I don't have an ORCID ID. Why? Because if you go on Google, I'm the first and last thing you find. I'm globally unique. So I'm easy to identify. Does that cause me a problem? Well, yeah, sometimes. So I was recently made unemployed, and I had to go and think about my CV. If I had an active, up-to-date ORCID record, and maybe combine that with my LinkedIn, that could be my CV. Instead of which, I had to go and manually make updates, which was an absolute pain, especially when it came to my publications list, which I hadn't updated for God knows how many years. So I went into DataCite Commons. So DataCite Commons is DataCite's discovery portal. It enables searches of all DataCite DOIs, a large subset of Crossref DOIs, people with ORCID IDs, organizations with RAW IDs, and DataCite member repositories. So great, I went in, I did a search, I found lots of mentions of me. Great. It includes all sorts of versions of my work, and it includes Zenodo concept DOIs, which are kind of these umbrella DOIs that capture all the versions. So this 177 isn't 177, but I have to go through individually, record by record, to check which one is which version and which one I want to cite in my publication list. This took a lot of time. And, of course, DataCite Commons doesn't include things that don't have DOIs, so there's a subset of things that are missing. So if I'd had an ORCID ID, I could have added everything missing to my record, and I could actually do it automatically for anything that was in DataCite Commons. So you'll see here there's this add to ORCID record option that I could have done. Poor metadata is a reality. Not everything with a PID has rich, up-to-date metadata. PIDs really are only as useful or as good as the metadata underlying. That needs to be as complete as possible, but only exposing what can be exposed. But metadata completeness takes work. It requires some level of strategizing. It really should be, metadata should be generated as early as possible, when the research output is at its birth, ideally, because it's really hard to retrospectively go back and create metadata. And you need some level of standardization. You know, if you've got a bunch of PIs across a department, they may all be collecting different metadata, so there needs to be some level of commonality. And it's also not a one-time exercise. Over time, related outputs are created, projects evolve over time, so on and so forth. There's also citation limitations, so not all PIDs can be easily cited in scholarly literature. The publishing process has limitations. ORCID IDs, RAW IDs are usually captured, but only really text-based documents are included in reference sections. So PIDs for anything else are normally included in line of text or stuck in data availability statements, supplements, acknowledgements. That means they're not necessarily fully machine readable. They're not necessarily indexed. There are techniques that have been developed for getting that information, and talks are really ongoing with the published community about changing practices. A related thing is that there can be quite often restrictions, quite strict restrictions, around the number of things that can be cited. But a study, for example, with samples could have hundreds or thousands of samples. There are groups such as the Complex Citations Working Group in RDA. They're working on solutions, but realistically, there's some way to go still. So what happens when we're in a situation where PIDs do exist, because they do? They have rich and complete metadata, which lots of them do, and they can be easily harvested. Well, that complete metadata includes relationship metadata that represents the connections among research outputs entities with PIDs. Those combine to form what's known as the PID graph. I am going to be a few minutes over, though. I do warn you that. This enables us to get an overview of the research landscape and also surfaces previously unknown connections. But generating that relationship metadata does take ongoing effort. But it is really, really assisted because all of these PID organizations, they do work together and they've created various integrations among them. So they help you create those links. And once those links exist, there's all sorts of interesting and powerful things you can do. For example, in DataCite Commons, you can get all these sort of visualizations among related outputs, researcher contributions, and things like that. So I don't have time again to go through this, but I strongly encourage you to go and have a look maybe at that link. You can see for yourself. So my original question, should you care about PIDs? So your job probably as a researcher is to do research. Should you put time and effort into this? Well, yeah, if you want someone else to discover and access your research, if you want someone to build on your research, if you want to get credit and acknowledgement for your research and your contributions, and you don't want to have to interfere too much with that on a human level, but allow the machines to do it, yeah, invest time in PIDs. PIDs are used in citations. We know this. They form the foundation of citation indexes, such as CH index. PID metadata schemas, they can capture both the main creators, but also contributions to work. So if you can ensure that if you were involved in research, your contribution is noted. When it comes to discovery, access, and reuse, I'd like to refer to the FAIR principles, so findable, accessible, interoperable, reusable. It's a nice acronym for what all good data repositories have been doing for many years. And you'll see that PIDs are the very first thing mentioned, and metadata are the second thing mentioned. And really, all the other principles go back to these first two principles. So PIDs and metadata are absolutely at the heart of findability and accessibility, that's a given, but also interoperability and reusability. So PIDs enhance interoperability. They provide common standards. They make it easy to integrate metadata and outputs across different systems. They enable reuse. You can reference things with confidence. You can know about the versioning, the provenance, the licensing. You can properly attribute the original authors. Lastly, if you happen to work in any sort of people or places related discipline, you might have heard of the CARE principles for Indigenous data governance. These are often operationalized by implying local context, traditional knowledge, or biocultural notices and labels, and these can actually be included in the metadata as well. So if you happen to know about this or are interested in this, this is something you can do. How do you archive your research outputs and obtain a PID? Well, the first place port of call is probably your university or institution or library. They may have, there may be one or more institutional repositories within your university which they can point you to, or they may be able to suggest a repository. Otherwise, go and look in, for example, for Re3 Data. So Re3 Data is the registry of research repositories, which also helps power DataCite Commons, and you can look things up there. Finally, if all else fails, you can also look at generalist repositories. And a very good example is the one sponsoring this particular workshop, Depositar. So you can go to Depositar and put your research in it and get a PID. You might also want to consider whether or not a repository has been certified. So when we were creating the Core Trust Seal requirements for the trustworthy digital repositories, we actually included the vital importance of PIDs in requirement R12, and it basically means that every Core Trust Seal certified repository is implementing PIDs as part of its research data management strategy. But what if you're a researcher that is in the early stages of your career? I don't have publications. Well, how can I say I'm actively involved in research? Well, a good option is to get a RAID. If you get a RAID for your project, you can actually link this to your ORCID record and highlight your research. Finally, I'd like to briefly look at the PID situation in Taiwan. So, I went through the Crossref API. I went through all 24,000 plus records in the API, searching for organizations in Taiwan. I may or may not have miscounted, but I found 41. Members registering DOIs for journal articles. That's quite a lot lower than I'd expect. I would have expected somewhere between 100 and 300 at a minimum, and probably more. DataCite only has one member in Taiwan, NYCU. It also has one consortium organization, SRDA here in Academia Sinica, and it's got of the 106 million plus DOIs. About 3,500 are actually been registered by Taiwanese researchers, and most of them by SRDA. The ORCID consortium in Taiwan is doing a little bit better. It's led by NYCU. It's got 8 members, which is okay. I mean, hopefully that'll grow. But I would say the fact that it's got 56,000 active records, which is 37th globally, is pretty good going. So Taiwanese researchers, research organizations, journals, they don't really seem to be using Crossref or DataCite DOIs extensively. Is that because we're looking in the wrong place? Are they using other DOIs? Well, not really. I mean, the DOI Foundation, which governs the DOI system, has 12 RAs. It includes Ariti, which is actually based in Taiwan. But Ariti is a for-profit organization. All the others are non-profit. And this seems to be obviously a major barrier. Ariti DOIs are not commonly used by Taiwanese research institutions for research outputs. So Taiwanese researchers are missing out on increased discoverability and credit for their work. And this is why I would really like, again, to encourage Taiwan to invest resources in developing and executing a national PID strategy. Does that make a difference? Well, let's take Australia as an example. It has a similar population to Taiwan. And a 2002 report found that the use of PID investment could save the Australian research sector nearly 38,000 person days per year through avoiding rekeying information and so on and so forth, and nearly 24 million Australian dollars, which is about 535 million Taiwanese dollars per year. If you want to find out more about, learn the experiences of other countries, if Taiwan wants to do that, then there was actually an RDA working group on national PID strategies that mapped the commonalities across national PID strategies and the PIDs adopted. They have a number of case studies. They also have created this guide and checklist. And I, again, strongly encourage you to go and look at that. So that's pretty much everything I want to say. So in summary, do we need a PID for everything? No. But if you want to uniquely reference something, it needs one. Does everything that have a PID should have one, actually have one? No, but we can change that and fully realize the optimized research lifecycle. Does everything that has a PID have rich, complete, up-to-date metadata? No, but we all collectively need to ensure that everyone has the information they need about outputs and entities. Can PIDs be fully utilized to enable attribution and credit? No, not yet, but we're getting there. And should I care about PIDs? Yes, yes you should. PIDs are really, really, really useful. Creating and maintaining PIDs and PID metadata, it takes time and work, but I can promise you it's ultimately worth it, and that's my take-home message. And